This is Algebra 2, Lesson 5.6, the quadratic formula and the discriminant. We are solving equations using the quadratic formula, and then we're using those in real-life situations like falling problems and problems like that. This is the most, this is an easy concept for most students to understand using the quadratic formula. What people forget is what the actual quadratic formula is. What I'm going to do is on the first couple of tests, I'll provide it for you. It's negative b plus or minus the square root of b squared minus 4ac over uh, over 2a. Okay, that's the quadratic formula. This is an easy concept for most students to understand because you guys, when you look at it, you know you can plug everything in the correct spots. But not stepwise, but just figuring wise, there are the most opportunities to make a mistake on this one. Even though it's easy, when you do the arithmetic, there's more chances to make a mistake on this way to solve quadratics than any other way. This is the most foolproof method of solving quadratics. The first way we learned to solve quadratics was to factor it out. Like if we had something that said x squared plus 2x plus 3, for example, we could factor that out by taking x times x and then taking the factors of c, 1 and 3. And this one's not going to work because I have two pluses, 1 and 3. But then looking at the signs and changing it and making one of them plus and one of them negative and stuff like that. That was the first way we learned. The second way we learned was the way we talked about last week when you completed the square. And in fact, this example that I tried to make just now would be one of those examples where you have to complete the square. If it said equal to 0, we would have to complete that square since plus 3 won't get me back to positive 2x. So what we would have to do, like we did last week, was bring 3 over and make a new value for c, x squared plus 2x plus c is equal to negative 3. And then we would go through our method of doing that last week by moving it over and taking the square root of the perfect trinomial. This method right here, using a quadratic formula, like I said, is the most tedious method, but it's also usually the easiest method for students to understand. Okay, so let's talk about what that looks like in just a second. The discriminant, just like on our bell work, is b squared minus 4ac. You'll get used to that because when you look at just this value, it tells you how many answers you're going to get out of this. There are 3 different options when it comes to answers. The first option is you're going to get your order. I'll do them in the same order that they go in. So let's get to that in a second. The quadratic formula says let a, b, and c be real numbers. Okay, so we've talked about numbers in here so far that are not real numbers. You guys have been exposed to complex numbers called imaginary numbers. So let a, b, and c be real numbers that are not equal to 0. That's what that says. Because if anything's equal to 0, then it's like multiplying something by 0. It eliminates that part of the problem. So just to where we can have all 3 of these numbers accounted for, let them not be equal to 0. Negative b, and this is the most common mistake that I see out of this right here. This negative b right here. If the b value would be negative, it's negative already, and then you're plugging in a negative value. Remember, that's going to make a negative negative, which is going to make it a positive. That's the most common mistake I see out of this, that first little bitty tiny part right up front. Everybody does everything else right and miss that part right there. But it's negative b. We have been exposed to that plus or minus symbol right after it. This represents 2 separate answers. One of them is plus, and the other one is minus. So most of the time, if you have an irrational number, you can simply write it as plus or minus. But remember, if for some crazy reason, not crazy, but if for some reason it comes out to be a perfect square and you can factor it out, remember you're going to have to do it as 2 separate problems because you'll get 2 separate answers. So plus or minus the square root of b squared minus 4 times a times c over 2 times a. And again, most students don't have any issue just plugging all of those values in and then simplifying it. So let's take a look at example number 1. The first option, there are 3 different options. The first one is a quadratic equation that has 2 real solutions. So we're going to come up with 2 of them. What that means is that under your radical, you're going to have a positive value. Because if it would be a negative value, then it would have to be an imaginary solution. Remember that, because there's no square root of a negative value. So right here it says 3x squared minus 3x minus 5 is equal to 0. So what we can do is we can label what everything is. We know this is A, this is B, and this is C. And again, most of us can mentally do that without having to write anything. But for the sake of the argument, we have it all labeled right here. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. Everything up here acts like a grouping symbol. Remember, this line right here acts like a grouping symbol. It means you have to try to simplify everything on the top before you divide it by what's on the bottom. And likewise, you have to simplify everything on the bottom before you try to divide the top by it. The radical itself, this, also acts like a grouping symbol. So you have to try to simplify everything under there before you interact with negative b plus or minus that. Okay? But that's the quadratic formula. So here they are all labeled. We labeled them just a second ago right above it. And now this is all of the values subbed in. Notice it says 3 right there. The very first number is 3. Why does it say 3 instead of negative 3? It's not b's value, it is negative b. So remember, it's negative already, and then b's value is negative 3. So that's negative 3. That's why it comes out to be a positive 3 at that point. Positive 3 plus or minus the square root of negative 3 squared minus 4 times a times c, 3 times negative 5, over 2 times a, 2 times 3. So then you simplify what's under that radical, the square root of everything under that radical. Negative 3 squared is positive 9. Negative 4 times positive 3 is negative 12. Negative 12 times negative 5 is positive 70. Positive 60. Positive 60. So you have 9 plus 60 under that radical. And 2 times 3 is 6. So now look and see what it says. 3 plus or minus the square root. We had 60 plus 9 is 69 over 2 times 3 is 6. So now it got a whole lot shorter. But now we're dealing with an irrational number. 3 plus or minus the square root of 69. The reason that this is not, the reason if all the way back at the top of the problem, this is 2 real solutions, is because look at what that square root says. That square root says a positive number, 69. Since it's a positive number, we know that there's not a negative value. So 3 plus or minus that, and all this is right here is each of those separate. 3 plus the square root of 69 over 6, which is approximately, notice that little wavy equal sign. That's what this is supposed to be, everybody. You can't quite see it. This is supposed to be about 1.88. And same thing with this one. 3 minus the square root of 69 divided by 6, about negative 0.88. And both of those are real values. Okay, I know you don't have an entire backside to do this example that's coming up on it. So in the margin or right below it, let's try this one. Solve this one. 3x squared plus 8x is equal to 35. You have to do something to this one first before you can solve it. You don't want it to be equal to 35. You want it to be equal to 0. How do you make it equal to 0? Okay, so the first thing we have to do is we have to move over 35. In order to do that, you have to subtract 35 since it's positive because you want it to be equal to 0. So now what we have is A, B, and C. 3 is A, 8 is B, C is negative 35. Remember, the sign goes with it. So from there, there's our quadratic formula on the right there. Again, I know this is long, this is tedious, this is boring. It is all three of those things. But this is foolproof as long as you are careful and you don't make a mistake like I'm about to make in a second. I'll show you the mistake in a second. But this is everything plugged in. B's value, remember, it's negative B, and since B is positive 8, it's negative 8, plus or minus B squared, 8 squared, minus 4 times A is 3, times C is negative 35, over 2 times 3 is 2, or 2 times A is 2 times 3. So when you multiply all of this, 8 squared is 64, negative 4 times 3 is negative 12, and negative 12 times negative 35 is not positive 410, it's positive 420. Okay, so that's just underneath the discriminant right there, underneath the radical, which is the discriminant. And 2 times 3 is 6. So when we have the square root of 64 plus 420, it's not going to be 475. I made even another mistake on top of my mistake. We're going to change it right now. It's not 475. It's 484 is what it should be. Okay? So that's not a perfect radical. So for the sake, we could possibly simplify that and make it a smaller radical. But since we're talking about irrational numbers anyways, and we're talking about making this into an approximation, this is what I mean, I'll show you this in just a second, we're going to take this and separate it into two real numbers, because it's still, even though it's an irrational number, the square root of 484, it is a real number because it's not a negative value. So negative 8 plus that square root of 484, not 475. Again, I made those same mistakes. Let me change them. So the square root, negative 8 plus the square root of 484, and negative 8 minus the square root of 484. And when you take those values, okay, the square root of 484, most of us, myself included, that's why I didn't say this a second ago, don't know that that's 22 times 22. Most of us don't go that far with our perfect radicals. But it is the number 22. So what that means is this right here is negative 8 plus 22. And again, it's not the square root of 22. It's just 22 over 6. And negative 8 minus 22 over 6. So negative 8 plus 22, that's opposite signs, so subtract those. 22 minus 8 is 14 over 6. The number 2 goes into both of those. It goes into the top one 7, and then into the bottom 3 times. So 7 over 3 would be one of your solutions. And negative 8 minus 22, those are the same sign, so add them up. 8 and 22 is 30, and keep that common negative. Negative 30 over 6 is negative 5. So those are your two real number solutions, one positive and one negative, but neither one is a complex number, neither one is an imaginary number. Negative 30 over 6. And again, look how long it took us to do this problem. This is the one thing about the quadratic formula. It is relatively easy unless you make mistakes like I did, and I'm actually glad I made those mistakes to show you just how easy they are to make. But you can, just from an arithmetic standpoint, you can make a very simple error which will cause your answer to come out to be incorrect. That's two real number solutions. Let's talk about the next option, one real solution. Now, one real solution are numbers that are going to come out to be equal to 0. So right here it says x squared plus 4x plus 11 is equal to 7. So we want, since we have a C value 11 and we have a number that's not 0 on the right, we want to make that number equal to 0. We want to bring this 7 over to the other side. So in order to bring it over, you subtract 7. Notice when we subtract 7, we get the number 4. 11 minus 7 is 4. And we get the number 0. When you're talking about it being equal to the number 0 on the right, we're going to get one real solution. Actually, we'll talk about that in just a second. But again, A, B, and C. A is 1. That's the unshown one, 1. B is this 4. C is this 4. So 1, 4, and 4. The same quadratic formula. Negative B plus or minus B squared minus 4AC over 2A. So negative B's value is 4, plus or minus B's value is 4 squared, minus 4 times A is 1, times C is 4. So when we simplify this, 4 squared is going to give us 16. Negative 4 times 1 is negative 4. Negative 4 times 4 is negative 16. So under the radical, we have 16 minus 16, which is going to be the square root of 0 underneath it. And then at the bottom, 2 times 1 will give us 2. Notice we can see that on this next line. Negative 4 plus or minus the square root of 0. Anytime you have the square root of 0, this goes back to this here, it being one real solution. Anytime you have the square root of 0, it's one real solution. So if you have a positive value there, you're going to get two real solutions. If you have 0 there, you're only going to get one real solution. Because negative 4 plus or minus the square root of 0, the square root of 0 is just 0. So it's negative 4 plus 0, which is negative 4 over 2, and negative 4 minus the square root of 0, which is negative 4 over 2. Notice both of those are the same. The solution is negative 2. That's why it only has one real solution. So if you plug that back into the original equation, x squared plus 4x plus 11 in place of x is equal to 7. Negative 2 squared is positive 4. 4 times negative 2 is negative 8. So 4 minus 8 is negative 4, plus 11 is equal to 7. So 7 is equal to 7. You get a true statement. And again, next to that one in space, this one's, again, will be a little bit shorter and a little bit quicker. Solve this one. Notice it's not in standard form. 12x minus 5 equals 2x squared plus 13x. Leave your A value positive if you can help it. It'll make it easier. Move everything else to make your A value positive. See if you can handle this one. All right, let's talk about this one again. Again, I mentioned as you were beginning to leave your A value be positive if you can help it. So everything's backwards on this problem just to start. Once you get past the beginning, it's a little bit easier though. So if you want to keep A value being positive, you want to keep that 2x squared as positive. So you don't want to move it to the other side of the equal sign. So you want to leave that there, which means we need to bring the B value to 12x over to the right. It is positive 12x. So in order to bring it over, you have to subtract it. When you subtract it, it becomes negative 12x. Notice I brought it over to the right and made it negative 12x. You also need to bring that negative 5 over there because you need it equal to 0. You don't want to have that negative 5 on the left, so you add 5 to the left and add it to the right. 13 plus 0 gives you 18. Now you have something that says 0 is equal to 2x squared minus 12x plus 18. You have A, you have B, and you have C, and it's equal to 0. Take that and plug it into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. Again, you have all of your values. So x is equal to negative 12 plus or minus negative 12 squared minus 4 times 2 times 18 over 2 times a, 2 times 2. So negative 12 gives you a positive 12 plus or minus negative 12 squared is positive 144. Negative 4 times 2 is negative 8. Negative 8 times 18 is negative 144. So under the radical, you have 144 minus 144 over 2 times 2 is 4. When you simplify this, 144 minus 144, you get 12 plus or minus the square root of 0. Notice on top of that, I just eliminated that part of the problem, plus or minus 0. You're not adding or subtracting anything from it. So it winds up being one real number solution, 12 over 4, which is 3. So you have one real solution, and that solution is the number 3. The next one is two imaginary solutions. So this is the third option. The first option was two real solutions. The second option was one real solution. The third option is two imaginary solutions. So if we had a positive number under the radical, it was two real numbers. If we had 0 under the radical, it was one real number. For this one, we have two imaginary solutions. We are going to get a negative value under the radical. So you have x squared minus 4x is equal to negative 8. That negative 8's got to come over. It becomes positive 8 to make it equal to 0. So you have A, you have B, and you have C. In the quadratic formula, negative B, negative 4 becomes positive 4, plus or minus. B's value is negative 4 squared, which is going to be positive 16 in a minute. Minus 4 times A is 1, times C is 8. Over 2 times a, 2 times 1. So negative 4 times 2 is positive 16. Negative 4 times 1 is negative 4. And negative 4 times 3 is negative 32. So under the radical, we're going to have something that says 16 minus 32, which is going to say negative 16 right here. So 4 plus or minus the square root of negative 16 over 2. Now we know what the square root of 16 is. We know it's 4. But we also know that there is no number that you can multiply by itself to give you a negative value, in this case, negative 16. So the way we can eliminate that, at this point right here, we know that there is no real solution to this problem. But there are two imaginary solutions. We know how to take that negative out from under that radical. We multiply it by I. So what we wind up with is 4 plus or minus I times 4, or 4 times I. So look at this right here. Now it says 4 plus or minus 4I over 2, because the square root of 16 is 4. So at this point, just like the first example that had two real solutions, now it's going to say 4 plus 4I over 2 and 4 minus 4I over 2. And again, that's what this symbol right here means, both plus and minus. So 2 plus, okay, so what we can do is we can simplify this. 2 goes into itself once, and it goes into 4 twice, and into 4 twice. So notice we just eliminated the fraction. So again, same thing. Just one more step, make it a little bit shorter. 2 plus 2i and 2 minus 2i. So it's both of those answers. Where it tells you to check your solution, you want to check and see if it works. So the original equation said x squared minus 4x is equal to negative 8. So if we take 2 plus 2i squared, you take that entire binomial, 2 plus 2i, and you square it. So 2 plus 2i times 2 plus 2i. When you FOIL that, and then you subtract 4 times, you distribute this one, go a little bit quicker right here for the sake of time, you get 8i minus 8 minus 8i. And again, I know they took a lot of steps off in between those, but just for the sake of time, notice your like terms, 8i and negative 8i. These cancel each other out and leave you with negative 8 is equal to negative 8. Negative 8 is equal to negative 8. And we'll pick up the rest of this tomorrow.